Hello guys, in this video we are doing inverse of a parabolic function. So I want us to see how to find the inverse of a parabolic function, as well as to check whether its inverse is still a function or it ceases to be a function. So let's consider the function f of x is equal to x squared. But to find the inverse of this one, step number one, say y is equal to x squared. Then variables have to interchange. This will give us x is equal to y squared. So y squared is equal to x, and we apply the square root. Y will be equal to root x. But on the square root, we know that we have plus or minus like this. So meaning y will be equal to plus or minus root x. From the definition of a function, one input gives you one output, or many to one, meaning many inputs must give you one output. But in this case, let's say we say x is equal to 1. If we apply, our y will be equal to plus or minus square root of 1. Then the answer will be plus 1 or minus 1. So now we have one input giving us many outputs, which means this is no longer a function. Therefore, you cannot define it as f inverse. You rather leave it in the form y is equal to square root of x. Let's also check another method that can help us to show us that it is no longer a function. It's a graphical method where we use the vertical line test. So let me sketch the two graphs. Y is equal to x squared and y is equal to square root of x. So this is our Cartesian plane with x and y axis, and this is the line y is equal to x. Since we know that the inverse of a graph is the reflection in the line y is equal to x, the graph of x squared is like this. Then the inverse of this graph, it too looks like this. A vertical line is just any vertical line that runs from the top to the bottom. So for it to pass the vertical line test, it should be cut at one point. So if the vertical line cuts at 2 points, it means the graph or the function will be no longer a function. So let's see, this is our vertical line. For f, which is the graph of x squared, this vertical line is cutting at just 1 point there. There's no other point it is cutting. Therefore, that one have passed vertical line test, so it's a function. But its inverse now is cutting at this point and that point. But there are some of the things that we can do to make the inverse of parabolic function a function also. To make an inverse of a parabola a function is by restricting the domain. That is x greater than or equal to 0, or x is less than or equal to 0. So let's sketch the graphs of f of x is equal to x squared. So we want to restrict the domain that x is greater than 0 and x is less than 0. So the graph of x squared. We know that the graph of x squared will be like this, but we want to restrict the domain. This one is x greater than or equal to 0. When x is greater than or equal to 0, meaning we only want to show this side of the graph. So our graph will look like this. So its inverse, by reflecting this graph around the line y is equal to x, which is the reflected part of the graph. So this is our vertical line that is going to cut the graph of inverse. Now it is cutting at 1 point like this. So now the inverse of f of x is a function. For this side, we have restricted our domain. X is less than or equal to 0, meaning it's this side. If we reflect it about this line, y is equal to x, we'll see something like this. If we do the vertical line test also, this is now the vertical line that we have drawn here. So it is now cutting our graph at 1 point. Then it has passed the vertical line test. Hence, the inverse of f is also a function.